Hi guys, and welcome back to Physical Sciences for Year 10 in the Australian curriculum. In this video we're going to be explaining how hydroelectric power works and use this as an example as an alternative power source or energy source. Okay, now hydroelectric power uses the concept of water, and water basically is going to be moved from high areas to low areas and generate electricity. Now down the bottom here I've got one of the classic hydroelectric power stations, which is the Hoover Dam in Colorado, on the Colorado River in America. Now basically what a dam does is it stops water and it raises the level of water up. Now obviously as we raise the level of water up, you've got GPE, you've got gravitational potential energy. Okay, so what you can see there is the river has been held back by the dam. Well, now the dam is made up of concrete. It's really thick. Now running through the dam there are going to be tubes, tunnels, which they call the penstock. Now when you try and get a large volume of water to move through a very narrow tube, basically you get water moving incredibly quickly. Take your thumb and stick it on the end of a hose pipe when it's running. If you let it run normally, then the water just flows out. You decrease the size of the hole or the bore that you've got, and the result is the water will come out quicker, which means you generate larger kinetic energy. Okay, so there's your energy transformation. You've gone from GPE to kinetic energy because we've changed the energy. So the water moves from high areas down through the penstock into low areas or small tubes, and we generate a large amount of kinetic energy. Now, put in that way a water wheel, we call that a turbine. Okay, the water wheel will turn as the water flows through it. Okay, and you can see the turbine there on the diagram of inside the hydro power plant. That will turn. Now that is then linked by an axle to a magnet. Now a magnet sits inside the transformer, which is basically made up of a magnet, a round magnet, and then around it you've got electrical wires. Now, I won't go into the process as to how that electrical energy is generated. We do that in senior physics. But basically, as the magnet spins, it has the effect of pushing electrons inside the wire around, and it pushes them in one direction, and the result is by pushing them in one direction we generate what we call a current, because we've got a flow of electrons. That is our electricity. So water goes from GPE down into kinetic energy, drives a turbine, which drives a magnet inside a coil of wire and generates electricity, which is then transferred across the national grid and into our homes. Okay, so let's just recap. We've got energy transformation which is occurring. Now the energy transformation, GPE to kinetic energy is then transferred from water to the driving of the turbine, which is then transferred to the driving of the magnet, and then it is generated into electricity as it push the electrons. So we've got GPE to kinetic energy and kinetic energy to electricity. Those are our energy transformations. So we've got gravitational potential energy of water to kinetic energy. We've got kinetic energy of water is transferred, notice the word transferred there, to kinetic energy of the turbine, and then we've got kinetic energy of the turbine is transformed into electrical energy. So again, we're using those two terms, transference and transformation. So we can put that in a flow chart, which can be shown here. There's your GPE, water in the reservoir, KE in the water, KE in the turbine, KE in the magnet. Now I've linked them there with blue arrows. The blue arrows represent energy transfer, and then the red arrows are going to demonstrate energy transformation. So we've got energy transformation from GPE in the water to KE in the water, and we've got transformation from KE in the magnet to electricity in the wires. So that is the flow of energy. The key thing about hydroelectric power is that there's no wastage. Okay, all you need is for it to rain. The reservoir needs to be full, and as a result, you'll generate a lot of electricity. In New Zealand, virtually 100% of the electricity is generated in this format. Because of the contour of the island or of the country, you've got the Alps, which mean they catch a lot of water, they flow to the sea. By damming the rivers, you're going to generate a large amount of GPE. By putting in your penstocks, you've then got your tubes to generate kinetic energy to flow really, really quickly, and as a result, you'll get your turbines and you generate your electricity. So it's very, very easy, and New Zealand does this very well, and it transfers it right across from the South Island to the North Island. We've got our Wivenhoe Dam here and the Hines Dam, which basically will generate hydroelectric power in Queensland. Okay, so what I'd like you to do is there's a couple of YouTube clips which I've put on this post, and they will talk in a little bit more detail about how hydroelectric power works, not only here in Australia but also around the world. Check them out, really good source of information about how hydroelectric power works. Okay, well, thank you for watching, and join me again. The next video we're going to be looking at will be looking at different alternative energy sources. So thanks for watching.